today we're talking about geometric distribution. Okay, so the definition for that is probability of success after probability of success after certain number of failures. This is a layman definition. It's not like a proper definition. Okay, so what does this mean? This means like if you're throwing a dice and you have to find that the probability of getting a 3 is on the 5th attempt. So you have to find probability of getting 3 on the 5th throw. So that would mean the first time you do not get a 3, the second time you do not get a 3, third, fourth, you do not get a 3, only on the 5th throw you get a 3. So probability of success is getting a 3, which is 1/6. Probability of failure is not getting a 3, which is 5/6. So probability of getting a 3 on the 5th throw would mean probability x is equals to 5. Probability of getting a 3 on the 5th floor is represented by probability of x is equals to 5. That means the success occurs on the 5th attempt. So first 4 times it's a failure. So you're going to write 5/6 times 5/6 times 5/6 times 5/6 or 5/6 power 4 times 1/6. And find the probability in decimals using calculator. So this would be the probability of getting a 3 on the 5th attempt. So on the first 4 attempt, you do not get a 3. And in the 5th attempt, you get a 3. This is called a geometric distribution. There are certain conditions for this to be applied. One of them is that probability of success is constant. And events are independent, like throw of dice. Okay. Now I'm going to write a couple of formulas that you need to note down. So for geometric distribution, the event is represented by G and the perimeter of interest is P, the probability of success. So probability X equals R means that probability of getting a success is on the rth attempt. I mean, you get a success on the rth attempt. Before that, you get failures. So this would be Q power R minus 1 times P. Then you might be asked to find probability X is greater than R. So that would be probability X is greater than R is just Q power R. Okay, similarly, sometimes they give you probability X is greater than equals to R. But this formula is for greater than R, not greater than equals to R. So what you'll have to do in that case is write this as probability X is greater than, go one value back. So for example, if this is 3, the third attempt, you go one value back to the second attempt. So it's going to be probability greater than 2, or in this case, R minus 1. So if they ask you, find that you get a 3 on the greater than equals to the fifth throw. So then you go to the fourth throw. You say probability X is greater than fourth throw, because this formula is for greater than, not greater than equals to. And then you get Q power R minus 1. Then probability X is less than and equals to R. Now there's equals to in the form. That is simply 1 minus this probability. So that's 1 minus QR. But again, sometimes in the question, they will structure the question in this way. They would give you data about less than R, not less than equals to R. So then this formula cannot be applied unless you go one value back. And then you get Q, 1 minus Q, R minus 1. Similarly, the mean in this distribution is just 1 upon probability. And the standard deviation is square root Q square upon P.
मैम पी जो मतलब कि सक्सेस की प्रोबेबिलिटी है
बिल्कुल। और Q क्या है?
फेलियर की
हाँ, फेलियर की। एक सेकंड, let me just confirm this last formula. It's actually Q upon P square. गलत लिख दिया मैंने. It's Q in the numerator and P square in the denominator. Okay. And if this is variance, that means square of sigma. So that's Q upon P square, square of standard deviation. Okay, now let's take a look at the worksheet questions. So most of these formulas would be given to you in the formula sheet. Just give me a second to show that to you. Okay, now not most of these, just these ones. Just these two formulas. So you would be given the formula for mean in a geometric distribution. Why not standard deviation? That is weird. Because they do give standard deviation of the other distributions, but not this. All right. So can't do anything about it. Okay, so you are given this first formula, this one. It's actually this. And then you are given, it's the same thing because Q is 1 minus P. So instead of Q, they've written 1 minus P. Okay, and then you're given this, just the mean. So that means it's very important that you have this memorized. and this memorized. And from here you can deduce this, and from here you can deduce this.
नहीं पीआर वाली फॉर्मूला समझ नहीं है मुझे.
कौन सा वाला?
पीआर वाला.
PR वाला? कौन सा?
पी और जो नीचे नहीं है
ये
ज्योमेट्रिक
वो,
डिस्ट्रीब्यूशन.
अच्छा अच्छा, it's just this formula. It's just this formula. They've written it in another way.
अच्छा अच्छा, मतलब क्यू को 1 - p किया
हाँ
हुआ.
हाँ.
ठीक है मैम.
Okay. Okay. A coin is biased, so that probability of obtaining a head is 0.6. Most likely, this is going to be RP. Okay. If X is the number of tosses up to and including the first head, so this is your hint or indication that you have to use geometric distribution. Let's read that again. If X is the number of tosses up to and including the first head, so you have to throw the dice many times till you get a head. So this is clearly geometric distribution. Okay. Find probability X is less than equals to 4. So we've already written this formula down. Probability X is less than equals to R equals 1 minus QR. So this is going to be 1 minus Q here is going to be 0.4. 1 minus 0.6. So 0.4 power 4, which is 0.9744. Probability X is greater than 5. So probability X is greater than R is just QR. So Q is 0.4, R here is 5. So 0.4 power 5, which is 0.01024. Question 2. In a particular board game, a player can get out of jail only by obtaining 2 heads when she tosses 2 coins. Find the probability that more than 6 attempts are needed to get out of jail. So you keep throwing 2 dices, two coins till you get 2 heads. So again, this is geometric distribution. Keep repeating an event till you get a success. So probability of success here is probability of getting 2 heads. So that's going to be half times half. So 1 by 4 is the probability of success, making Q 3 by 4. We have to find the probability that you get double heads on the 6th attempt. So probability X equals 6. And we know probability X equals R equals Q R minus 1 times P. So this is going to be Q power 5 times P, which is going to be 3 by 4 power 5 times 1 by 4. Oops, the question was something else. The question was find the probability that more than 6 attempts are needed. So this was not part A. Here, let's call it A1. And now let's do the actually this part. Find the probability that more than 6 attempts are needed. Probability X is greater than 6. So the formula for probability X is greater than R is just QR. So Q here is 3 by 5, 3 by 4, power 5. Sorry, it's going to be Q power 6. Why did I write 5? It's Q power R. So R is 6. So this would be the formula that we use, and the answer would be 0.178. Part B. Find the smallest value of n if there is to be at least 90% chances of getting out of jail on or before the nth attempt. On or before the nth attempt means probability X is greater than equals to n. Again, what's the formula for probability? X is greater than equals to R. We have a formula for probability X is greater than R, and that's QR. So if we need to include equals to here, we will have to use a value smaller than R, which is R minus 1. So this would become QR minus 1. Let me just check again. What is the smallest value of n if there is to be at least 90% chance of getting out of jail on or before? Oh, it said before, my bad. Just disregard what I've written. Let's reread the question again. What is the smallest value of n if there's to be at least 90% chance? So at least 90% chance means greater than equals to 90%. So 90% is 0.9. Okay. Of getting out of jail on or before the nth attempt. So it's going to be less than equals to n. And 1 minus probability X is less than equals to R is 1 minus QR. So this is going to be 1 minus Q power n. Greater than equals to 0.9. Okay. Do we have Q here? If P is 1 by 4, then Q is 3
इक्वल्स
by
टू
4.
90 नहीं करते उसको वैसे इक्वल्स टू 90 ओवर 100 अच्छा नेवर माइंड
At least 90% है ना?
जी मैं
So,
मैंने इक्वल्स टू लगा दिया था बाकी तो वही की है
okay. Q is 3 by 4, power n greater than equals to 0.9. The power is a variable. That means this becomes a question on log. So I'm going to rearrange this first, bring 3 over 4 power n to the other side, and 0.1 on the other side. 1 minus 0.9 is 0.1. Take log on both sides. Any log, ln or log 2, log base 2 on both sides, it just has to be the same. I'm just simply using log, which means log base 10. Okay, now the n comes here. Okay, now just make sure that this is not a negative value. Because if it is, then you divide with the negative value and you must flip the sign of inequality. It's very important to check this because sometimes this also is negative, and when you divide, you get a positive answer. So you don't know if you divided with a negative number or positive number. So always check what's being divided on both sides, that if is it positive or negative. So log 3 by 4, I believe, is negative. Yes, because it's smaller than 1. It's going to be some negative value. You can even check it in your calculator. Now, when you divide that on both sides, log 3 by 4, whatever is the answer of that on both sides, flip the inequality sign. It's going to be log 0.1 upon log 3 by 4, which comes out to be 8.0039 less than equals to 9, or 9 is greater than equals to 8.0039. That means 9 is n is equals to 9. It has to be an integer value because n is an attempt, can't be 8.0039. Okay, next question. आज की क्लास थोड़ी छोटी रखेंगे माजरत के साथ. The probability that a marksman hits the bullseye is 0.4 for each shot, and each shot is independent of all other. Find the probability that he hits the bullseye for the first time on the fourth attempt. So very clearly, this is a question on geometric distribution. So now you should be able to distinguish between binomial distribution question and geometric distribution question. बाइनोमियल डिस्ट्रीब्यूशन ऐसा होता था कि आपने डाइस फेंका है और आपने लेट्स से 6 दफा डाइस फेंके हैं, तो आपने फाइंड करनी है कि प्रोबेबिलिटी ऑफ गेटिंग अ 3 इज लेस देन 3. इस तरह का होता था. और प्रोबेबिलिटी और ये ज्योमेट्रिक डिस्ट्रीब्यूशन होता है कि आपने डाइस फेंका है तो आपका जो 3 आया है वो 5th अटेम्प्ट पे आया. तो बड़ी क्लियरली नजर आ जाता है कि ज्योमेट्रिक डिस्ट्रीब्यूशन का क्वेश्चन है या बायनोमियल डिस्ट्रीब्यूशन का क्वेश्चन. और इसमें एक चीज और रह गई है, नॉर्मल डिस्ट्रीब्यूशन. नॉर्मल डिस्ट्रीब्यूशन के क्वेश्चन में हमेशा लिखा होता है कि नॉर्मल डिस्ट्रीब्यूशन का मेंशन होता है. एनीवे, बैक टू दिस क्वेश्चन. The probability that he hits the bullseye for the first time on the fourth attempt, that means we're finding probability x equals 4. That means first 3 were failures, so q cube, and then there was a success. P is 0.4, so q would be 0.6. So this should be 0.6 cube times p. This comes out to be 0.864. The mean number of throws needed to hit the bullseye and the standard deviation. Formula for mean is 1 upon probability of success, 1 upon 0.4, which gives 2.5. Standard deviation is square root q upon p square. So square root 0.6 upon 0.4 square, 1.94. The most likely number of throws until he hits the bullseye. Okay. Is that's just the same as mean. So just ignore that. Question 4. Independent identical trials of an experiment are carried out until a success occurs. On average, 10 trials are required. If the probability of the trial is successful is P, find P. So on average, 10 trials are required. That means mu is 10. That means the average is 10. So 10 or mu equals 1 upon P. So all you have to do in this question is equate 10 to 1 upon P. So P would be 1 upon 10, which is 0.1. Question 5. Alice runs a stall at a festival where plays throw a die until a 4 occurs. So that means we have the probability of success, which is getting a 4 after throwing a die. So that's a 1/6. They have to pay a certain amount per throw and must keep playing until a 4 is obtained. So you keep throwing the dice until you get a 4. Then they receive $10. So at every throw, they have to pay a certain amount of money, maybe $1, maybe $2. And whenever they get a 4, they stop playing and they're awarded $10. So they can't stop playing unless they get a 4. How many should Alice charge per throw so that her expected gain per game is 50 pence? Okay. So if the expected gain is 50 pence, okay, so we're probably going to use the same formula. Mu is equals to 1 upon probability of success. So the mu is equals to 1 upon 1 by 6. So mu is 6, which means on average, at the 6th attempt, the person playing is likely to get a 4 on average. So then how much should she charge per throw so that she gets a gain of 50 pence? Gain of 50 pence means that she should be getting $10.5. She should be making $10.5. 6 throws, so divided with 6, which gives 10.5 divided by 6 is 1.75. So if she charges 1.75 per throw, then by the 6th throw, she would have a gain of $10, which is a gain of 50 pence, that is half a dollar. Okay, I'll have to end the lesson here today. Inshallah, we'll continue from here on Monday. Okay, take care. Allah Hafiz.